Small demo of an equivalent photovoltaic system to work on the control of the converter, so we can try to improve the efficiency of the system and have a better integration on the grid. So the system is constituted first of a power supply that reproduces the equivalent characteristics of the PV panels and that injects power on the grid through the photovoltaic converter that converts DC power from the panels to AC power to be injected on the grid. That is done through an LC filter. So we have here the filtering capacitors in the converter, and we have here the filtering inductors with active damping. So we remove the damping resistors to have a better efficiency, and we are damping the system with the control of the converter. Here is the point of common coupling. So this is the output of the photovoltaic system, and this is where it is connected to the grid. We can also have some loads in parallel depending on the test we want to perform. And then the power flows to the grid through the transformers. Here we have the displace interface that allows us to observe the different variables and control the system by regulating the power of the system. Now I will turn on the converter by increasing slowly the grid voltage, the PV array voltage, and increasing as well the power of the system. So we can observe there the grid currents, the DC currents, and we can have all the variables as well on the oscilloscopes. So we can see here on the right the grid currents, then on the left we have the grid voltage and the grid current that are in phase, and we also have the DC current and the DC voltage. So while the system is working, there is power flowing from the DC supply to the grid through the converter, and that allows us to perform different tests and evaluate the operation of the system under different conditions and try to improve the control of the converter that way. There I'm just increasing the power to have higher grid currents and higher DC current as well. Thank you for listening. That's all for the demo.